So big thing to keep in mind is typically your intervals go from negative pi over 2 to positive pi over 2. I forgot to change this. This should be a b here. If that's a b, this is the b, this is the b, lay. To graph a period of a tangent, y equals a tangent of b to the x, an appropriate interval would be negative pi over 2b, comma, pi over 2b. If you want to do the same thing with a cotangent, then your interval would be 0 to pi over b. And we'll get into cotangents here in a little bit. But for this next example, if we want to graph this function y equals a tangent of 2, and then we also have thrown in a phase shift. So we have x minus pi over 4. So this is your b value. And if you want to find an interval, or the period, well, that's going to be from negative pi over 2b, comma, pi over 2b. So if b is equal to 2, that means the period is going to be between negative pi over 4 to a positive pi over 4. So that entire distance, the entire period then, would just be a positive pi over 2. That's going to be the distance of your period. So when we plot in our asymptotes, notice I don't have any lines here. That way we can make our graph a little bit bigger. We're going to go out here to a negative pi over 4. Wait, I'll put there here. We're going to go negative pi over 4 and a positive pi over 4. And your normal graph would go between these points. Well, or your new graph with your periods that have changed. Going to go in between these two dots. The thing is, we're actually going to shift this graph to the right. This gives us a that's not annoying. We're going to shift right by a pi over 2. Our amplitude is still going to be a 1 because we have a 1 out front, and we're not really shrunk or stretched. So, aside from changing our period, so this would be like a vertical shrink or stretch. This is not going to happen. So what we are going to do is normally we'd have our graph in between these functions, but we are going to shift this to the right a pi over 4. So I need to get rid of these bad boys. And this is going to be shifted to the right a pi over 4. So that means we're going to have an asymptote at 0. So if we have an asymptote here at 0, there's my asymptote. Then we're also going to have another asymptote over here at, this is pi over 4. Then we're going to have one at pi over 2. So we need an asymptote over here at pi over 2. And we're still going to follow the same basic premise that when we're graphing these wonderful doodads, we're going to put a point in the middle. We're going to put that little dot there, and then halfway in between pi over 4 and 0, and halfway between pi over 4 and pi over 2. Well, if this is 0 and this is really a 2/8, then that would be a pi over 8. This would be a 3 pi over 8. Our graph is still going to follow this nice little S shape, and our amplitude is still at 1. Or I'm sorry, amplitude is still at 1. So what we're going to do is we're going to have our graph in the middle. We have this point. Halfway in between pi over 4 and pi over 2 is a 3 pi over 8. So we're going to go up a distance of 1 right here. So that's what we did on the last graph. And halfway between 0 and pi over 4 is a pi over 8. We're going to go down 1. So our graph is still going to follow this little S kind of shape. Go up like that. So that is a graph where your B, which changes the period, that's why this is all color coded for you, and then we have a shift to the right a pi over 4. So our period is usually from negative pi over 2 to pi over 2, but it was shrunk because we had a 2 out here for our B, and so this whole distance is a pi over 2. That would make sense because we got pi over 2 here. Amplitude still 1. You're not vertically shrunk or stretched, and you are shifted to the right by a pi over 4. So here is your wonderful graph. You put asymptotes, dot in the middle, halfway to the right you go up 1, halfway to the left you go down 1, unless there is a change in your amplitude. Lots of info, great info, I might add.